My name is Wyatt Rabita, and this is my Physics 2212 Lab 1 presentation. Introduction. The purpose of this lab is to determine the amount of excess charge left on a strip of tape after being electrically charged. The excess charge left on the piece of tape was 1.447 times 10 to the negative 8 coulombs. The materials used in this lab were a meter stick, some rolls of clear tape, and a desk. Let's go over some of the fundamental physics principles that were used in this experiment. First up is Coulomb's law. F equals K Q1 Q2 over R squared. K equals Coulomb's constant, which is 9 times 10 to the ninth power. Q1 and Q2 are the charges of the two objects, and R is the distance between the two. The second physics principle is gravitational force on Earth. F equals mg. This is a variant on Newton's second law, F equals ma, where a is equal to g, which is equal to 9.8 meters per second squared. And of course, m is the mass of the object. Here are the initial conditions of the lab. Two charged tapes were separated by a distance d, which was 0.031 meters. The tape had length 0.2 meters, width 0.02 meters, area 0.004 meters, and mass of 0.0002 kilograms. An atom has length 1 times 10 to the negative 10th power meters, and the area of the atom is just that squared. The total amount of atoms on the piece of tape is just the area of the tape divided by the area of an atom, which gave us an answer of 4 times 10 to the 17th power atoms on the piece of tape. Here is a model of the tapes when tape B is lifted by force exerted by tape A. The system is tape B, and the surroundings are everything else. The forces acting on tape B include the electric force from tape A and gravity. Calculating the excess electrons. Since a tape is left suspended motionless in the air, all of the forces, F net, must be equal to 0. This means that the electric force on tape B and the gravitational force on tape B are equivalent and opposite. The force of gravity is equal to the mass of the tape multiplied by the gravity constant, 9.8 meters per second squared. This yields 1.96 times 10 to the negative 3 newtons. The magnitude of the electric force is equal to this number, and the direction is opposite of the gravity's direction. Using the electric force, F_elec, finding the value of Q, the charge of the tape, is simple, using the formula F_elec equals QE. After plugging all of the numbers in, Q is left to be 1.447 times 10 to the negative 8th power, coulombs. Using the charge of the tape, we can now calculate the number of electrons lost per atom. The charge of the tape divided by the charge of electron gives us the number of electrons lost, which was 9.03 times 10 to the 10th power electrons. This number divided by the amount of atoms in a piece of tape shows that for each atom on the piece of tape, 2.257 times 10 to the negative 7th electrons were lost. To visualize these calculations, I used GlowScript to create a model of the two tapes in the form of point charges. This model shows the two tapes and the forces acting upon them. The yellow ball represents tape B and the green ball represents tape A, while the arrows represent the two forces, F_elec and Fg. When doing this experiment, we had to make a few assumptions. The first one was that air resistance is completely ignored for tape B when it is suspended in the air. Number 2 was that the long tape was treated like a point charge, meaning not all electric fields were considered for each of the charges on the tape. And number 3, each U-tape had the same amount of charge, which obviously is not true because each U-tape was handled differently. Here are some potential sources for error. 1, the distance between the tapes was hard to measure, so the true distance between them could be different. And 2, the tapes may have lost charge due to touching and handling them, meaning the excess charge may be less than calculated. Here are some extra questions. What if the charges of protons and electrons were switched? Since protons and electrons have charges of equal magnitude, switching the charge values would have no effect on the observations. Like charges still repel each other, so tape B would still float above tape A. And why is it important to handle the tapes as little as possible? Since the tapes have an excess of electrons, as time passes, they attempt to pass electrons to other objects they touch. Touching the tapes with your hands makes the tapes lose some of that excess charge that they had stored. Thank you for your time. This was my Lab 1 for Physics 2.